Well, good evening. We are Group 2 and we'll be presenting on lithium-ion battery industry. A lithium-ion battery, also popularly known as Li-ion battery, is a type of rechargeable battery that stores energy by the reversible reduction of lithium ions. It's the most common kind of battery used in electric vehicles and portable consumer gadgets. So there are three major applications for the lithium-ion battery. The first thing is portable device that includes all our mobile phones and smartphones, as well as laptops, tablets, and digital cameras. So it's also used in power tools such as garden tools, trimmers, as well as cordless drills and sanders. So its major application is um, in the present is used in electric vehicles, uh, such as electric cars, hybrid cars, electric motorbikes, scooters, uh, and all the other related vehicles. So when it comes to the market analysis, by the type analysis, it's based on uh, it's based upon five major types, that is lithium cobalt oxide, lithium iron phosphate, lithium nickel manganese oxide, lithium nickel cobalt aluminum oxide, and lithium titanate oxide. When it comes to geography, its presence is felt in five major places, that is North America, Latin America, Europe, Asia Pacific, and the Middle East and Africa. And Asia Pacific holds the highest market share, that is 47% out of the entire market share in 2021, followed by Europe and North America. By application analysis, it's again segmented into four: automotive, consumer electronics, energy storage, industrial, and others. The industrial use is the most when compared to the all the other four. And the market forecast is estimated to be about 278 billion US dollars in 2030. That is almost more than 300% when it compared to 2021, where the market was 58.61 billion. Over to Lakshmi Narayan.
So talking about the technology behind lithium-ion batteries, the major manufacturers in the world are Panasonic, LG, ASC, Elitech, Samsung, Toshiba, etc. So how do these companies differentiate their batteries? They basically differentiate it by the energy density of the batteries. The companies evolved in such a way that they develop different amounts of energy density with their batteries by using different components and different way of manufacturing. So they use a lot of proprietary technology which has been patented extensively. Before the years 2000 to 2004, the number of patents received were like around 120, but during the years 2010 to 2014, the number of patents have increased to 450. Also, the amount of research is not only done by manufacturers, suppliers, users, and manufacturers alike conduct research so that they can improve the processes which are involved in their own business models. For instance, let's say Tesla has been conducting research so that they could improve the mileage in their car batteries. They have been experimenting with lithium air batteries, and then the new technologies are like solid state lithium ion batteries, lithium metal batteries, lithium sulfur batteries, zinc bromine batteries. So what is the difference between these batteries? For instance, solid state batteries can store a lot of energy, meaning they have greater energy density. So they have been extensively researched by Toyota and Sakti to solve their electric problems. And then lithium air batteries also have an outstanding capacity of about 3000 mega ampere hour per gram as anode material. This has also been researched by people from MIT so that we can use it in EVs. Sulfur and bromine batteries are cheaper, but they can be used for stationary storage. Next slide, please. Over to Ishika.
So basically how the manufacturing system works for the lithium-ion batteries. This has been divided into 3 steps. The first step is the electrode preparation. It includes the following steps, that is mixing, coating, compressing, slitting, and drying. The second step is the cell assembly stage, which includes stacking, winding, packaging, welding, and filling. The third step is the battery electrochemistry. It includes the formation, aging, and the EUL testing. The manufacturing unit has some of the strategies for the manufacturing. That is the use of that they use the intercalation cathodes for the mechanics of the rechargeable lithium batteries. These intercalation cathodes have 4 different crystalline structures that are basically named layered, spinel, olivine, and telluride. It has been proven that a lot of different materials can be worked as an intercalation cathodes, but the transition materials and the olivine have been emerged as the best choice of owing to their excellent operating voltages. However, more researches are being carried out in this regard to achieve a high specific capacity range of these intercalation cathodes, because it will be regarded as another strategy to improve the working for rechargeable lithium-ion batteries. So basically, a huge number of strategies are here and there involved for the efficacy of for the ongoing material or the products. In the same way the lithium-ion batteries works, all the strategies like changing of the working mechanics and others have been formulated under strict observance, and all the experimental works they have been chosen to put forward for the industries to start introducing the different strategies. In this way, the manufacturing the efficacy of the rechargeable lithium-ion batteries can be improved and enhanced massively. Next slide.
So I'll be speaking about the major suppliers. So mainly we have 10 major suppliers, starting with Panasonic, which is, in case of India, it is the largest manufacturer and supplier of dry cell batteries and lighting products. LG Chem is a part of the LG Group and is the largest Korean chemical company. And it was the 10th largest chemical company in the world by sales in 2017. BYD is was China's biggest producer of LIVs in 2016, and it manufactures automobiles, buses, electric bicycles, trucks, forklifts, rechargeable batteries, and solar panels. CATL has a market share of 32.6% in 2021, and it's the biggest lithium-ion battery manufacturer for EVs in the world, producing 96.7 GWh of the global 296.8. Samsung SDI is ranked 6th in the world with a market share of 5% in the first half of 2022. Leshan Battery is a high-tech enterprise controlled by state-owned company and private shareholders, established in 1997 with a registered capital of 272 million. Its control to support the Chinese government's EV strategy. Leshan built new EV battery plants in Tianjin, Suzhou, and Qingdao in 2016 to triple its output to 10 gigawatts by early 2018. GS Yuasa Corp specializes in the development and production of lead acid and lithium-ion batteries used in automobiles and motorcycles. Automotive Energy Supply Corporation was formed in 2007 as a joint venture between NEC Corporation and Nissan to supply batteries to Renault Nissan. Its main plant is at Zama City, Japan, close to Nissan's main production complex. ATL is a lithium-ion battery producer and innovator, also responsible for providing high-quality system integration solutions. Wanxian Group, automotive components subsidiary, is the largest China-based automotive components company measured by revenues. Next slide, please. Over to Deepak.
Now coming to the supply chain, the first step includes the extraction of raw materials. The main raw materials in the production of LIB are aluminium, nickel, manganese, graphite, cobalt, and lithium. The main contributors to these raw materials are Alcoa, Albemarle, SQM, FMC, and Tanaka Corporation. The next includes the production of battery and other components. Anode, cathode, separator, electrolyte, and BMS are the production and the main contributors to this component are BM, Applied Materials, Unicorn, Etheon, Texas Instrument, Hitachi Chemical, and LG Chemicals. The next stage includes the battery pack manufacturing. The main contributors to this stage are Panasonic, LG Chemicals, BYD, Tesla, Samsung SDI, and LG Chemicals. Now coming on to the application of LIBs, the first is stationary storage, second electronics, which includes mobile phones, and the third is electronic vehicles, which is growing at a very fast rate. The main contributors to this stage are Tesla, LG Chemicals, BYD, Samsung, Google, Sony, Apple, etc. Now, anode, cathode, separator, electrolyte, and electrode foils are the bottlenecks of these 5 stages, including the raw materials, cobalt, lithium, nickel, and copper. Next slide, please. Now, coming on to the countries with major lithium production and reserves, Australia is the biggest producer of lithium with 51,000 tons, followed by Chile with 16,000 tons, then China with 8,000 tons, Argentina with 6.2 thousand tons. The rest countries, Zimbabwe, Portugal, Brazil, Namibia, and USA are small contributors to the production. Coming on to the reserves, Chile has the biggest reserves of lithium, followed by Australia, then Argentina, and then the rest of the countries, Zimbabwe, Portugal, Brazil, Namibia, and USA. Next slide. Thank you.
So that was the presentation of our group number 2, lithium-ion battery. Thank you. I'm going to stop recording this.